Hi, this is Cam Calderon and this is a quick video about using Solver to predict values for the house rent market. So I'm going to make a quick video covering a section where I predict the values for the fundamentals over using a Solver function. So let's go to my full desktop. So yes, so this is the section, the book that I want to cover with you. We have here, first of all, a set of equations. So the first equation that we have in here is the regression equation for net absorption. So you can see that is absorption, the first line here. I have previously changed the equation in this fashion. So as you can see, I pass the intercept to the left hand side of the equation, and therefore the specification of the model is as follows. I think I need to change the signs in here because they are minus after I pass the intercept to the left hand side of the equation. So this formula, net absorption, yes, this sum at the right hand side of the equation needs to be equal to the intercept. So that is why here the desired value is the actual value of the intercept that is in this book. Yes, and I did exactly the same for the other regression models that I calculated using multiple linear regression. Yes, so you can check here the actual values of the intercept. All right, apart from that, after inputting the regression there, I added some restrictions. These restrictions come from the data. So for instance, in the case, as an example, the case, this one is VR vacancy rates. Yes, vacancy rates is actually equal to vacancy divided by total stock. So you can see that here in the workbook data, right? So vacancy rate, as you can see, equals vacancy divided by the total stock. So that is exactly what I have here in the equation. And the only thing that I did is to pass all these variables in the right hand side of this equation to the left hand side. So at the end I got a vacancy rate times total stock divided by vacancy equal 1. And that is exactly what I have here. I have here the formula for the right hand side of the equation, and I say that the desired formula for this is equal to 1. You can check the other variables, yes, they are the same. In this case, it's a subtraction. So vacancy minus total stock plus occupied space equals 0, yes. And occupied space divided by space per worker times office employment equal 1. And I did as well absorption minus occupied space plus occupied space lack is 0. Yes, because it's a subtraction. Yes, and that is actually the formula for absorption. I also did new stock or new supply minus total stock plus total stock lack equals 0. Yes, so these are the desired values for these restrictions, and they make sense because they cannot get a different value. For the regressions, these are the intercepts, and they make sense because the value of those equations needs to be these intercepts. So these are then the equations that I am going to use, and because of this I have a system of equations that I'm going to try to solve using a solver here in Excel. Right. So what else? I have here office employment. I am going to assume that office employment is fixed. You can carry on like improving this, for instance, by adding a forecast after 2015 or 2016 period 1, which is this the figure for this. If you want to improve your results, as you can see from here, actually we will have some changes in office employment, yes, in one of these restrictions, yes, this one, yes, J2. So the actual occupied space probably is linked with this. So if you change or change this value, probably you will get a better forecasts below. That is another way to improve the actual result of this workbook. Okay, what else? We also have certain lags that were on the equations here and the restrictions. And these lags are going to help me to set even more restrictions for the model. Yes, so we will know the values of these cells already, some of the restrictions, and that is actually going to help me to find the values of these variables that are on here. Okay, I think that is pretty much what I did during the supervision, the third part. So let's try to find the values of these cells very quickly. So the first thing that I'm going to do is to find the lags for these values, right? So I'm going to find the occupied space lag. So I'm going to the data. I'm going to find occupied space lag. I have occupied space here, but I created like the occupied space lag already around here. So let's use it from here. It needs to be the one from 2016 quarter 1. Yes, that is the quarter that we are now predicting, because the statement of the exercise that we are using is asking us to make a partition after 2015. So we are going to use this one. I'm going to copy, yes, and I am going to paste. Oh, it's not doing it, so I'm going just to type equal this one. Right. Apart from that, I am going to use the prime rate lag, rent lag. So this equal to the lag of rent, which is in this case this one. Okay. So I'm going to hit enter. Yes. I should put as well here like a yellow color for everybody to understand what are the values that I am using. All right. I am going to find absorption lag equal. Absorption lag does not have a lag that I remember. Oh yes, lag net absorption as well. I can use this one, is ready from quarter 1. Note that I could have used the net absorption 2015 figure, yes, which is obviously in 2015 because it does not have a lag, the original variable. And I hit enter here, yes. I can put a yellow color for you to remember where I took the number from. So yellow color, yes. Also, I need, in order to run this regression, I think I am putting this in the wrong place. I can set the numbers in here, right? I need to find a total stock lag. So let's try to find the figure here in the data. Rents, lag, total rent, employment, lag occupied states, rent, vacancy rate, occupied space. It looks like I do not have a lag for total stock, so I am just going to use the figure of 2015 quarter 1. Why this one? Because that is the figure without a lag. So here it is. Oh, yes, total stock. Yes, so that is the total stock lag, and I am going to just put yellow color in my data. Yes, 2,443,000. 2 million. Oh, I think it looks like I use a different one. Let's check that. Oh yes, it's not this one. I use this one. 2 millions, 24 millions 101. 24,101. So everything is fine, right? So I have the values already for the first quarter that I have the data for predicting. So I'm going just to put to this a green color, yes, to work better. Yes, I can use, oh, I think I missed one here, the absorption lag. So I'm going to the absorption lag. Why jumps over off or something? Absorption lag. Absorption lag. I think I used it. Oh, right, so yes. Sorry, I think I made here a mistake because this one goes here. Yes. This one is net absorption. And I think I did not found vacancy rate lag. So I'm going to find vacancy rate lag in here, which is in here. It does not have yellow color. So I need to use this one. That is the vacancy rate lag. Okay. So I have already the values that I need for quarter one. This is for quarter one. So I am going to pull these results down because I need 4 quarters. Yes, 2015 quarter 1, 2015 quarter 2, 2015 quarter 3, and 2015 quarter 4. From that point, I will need to carry on using my predicted values in order to carry on out of the sample forecasting the rest of the data. Okay, so I can then Control C this, copy, and then I hit here, paste the special. I transpose the value and I ask transpose and ask Excel to paste the values. So I did so, yes, and then I have already the values for these numbers here, for these variables here. Next, I can delete these values, yes, I am going to do so, and I am going to calculate the values for the first quarter, 2016 quarter 1. The value that I can use here for SPW is 1, because as you can see I am dividing by 0. So SPW is here dividing something by 0, so I cannot just leave nothing in there. And also I have this other error, so I will need to set this one to 1 or any other number in order not to get a problem in my equation and therefore problems in running my solver. Now that these values are ready, I am going just to go to data, yes, solver, and you can appreciate here that my solver has a set objective, this cell, yes. I am going to set these solver parameters with the value of 0 for this equation, yes, the last equation. That will guarantee that I will get a 0 here if Excel finds a solution. I am asking Excel to set the results in these cells, and apart from that I set the restrictions that are in here, which are F2 equal G2, F3 equal G3, F4 equal G4, F5 equal G5, and so on so far. Okay, so all the restrictions are in here. Next, I click here in solve. It's iterating. Yes, I just to recall that what the solver does is to make iterations up until that is try and error up until it finds convenient values to solve these equations. I hit here in OK, and then you can appreciate that these values are actually the values that I need here for these cells. So I'm just going to Control C and Control V everything. Yes. So let's do this one. Control C, Control V, Control C, Control V. Oh, sorry for this. This one is vacancy rate. Control V. Yes. So I think I did not use SPW. It looks like it's not here. We can record the values as well here for SPW if we want. Yes, it's not all mandatory, but because we do not need the values, so let's carry on instead. Occupy the space, Control C. Where is occupy the space? It's here. Yes. Control V. Vacancy, Control C. Vacancy rate. Actually, we do not have vacancy here. We can set as well the values for vacancy if we want. Control B. I mean, it doesn't matter. Yes. And then we have total stock. Total stock is in here. Yes. New supply. And new supply. And then absorption. And where is absorption? Net absorption. Yes. And I think with this we found all the values in here. Now we are going to use the next solver. So we finish the values for these cells. Yes. I'm going to just to put the values here in another color. We can delete these values so it will be clearer the point. Yes. And then we find the next solver, which these values. Oh. So we paste the special values and we transpose. Okay, have an error there. So let's try again. Control C, and then paste special, values, and transpose. And we are ready for the next calculation. So we come back here, hit data, solver, and then OK, solve. It found an answer for the solution. We can check all the time that the solution is alright if our equations equal the desired value. Yes, and in this case you can note they are equal. We can use this answer perfectly, so it fits the restriction equations very well. So let's just Control C and Control V these values very quickly. Yes, vacancy rate is here. Occupied space, right, this one, vacancy, oh, I forgot to paste the previous value or something. Yes, I forgot. Oh no, I did not. Yes, vacancy, total stock, Control C, total stock, Control V, new supply, Control C, new supply, Control V, then absorption, Control C, then absorption, Control V, then we can run the next model, Control C, we paste the values, we transpose this because it's horizontal, we need it vertical, just to get these values, and then we click here, we go to the solver, we hit solver or solve, and then we got a solution. It's very good. Yes, all the coefficients, all the restrictions equal to what they need to be equal to, and then we are able to find the values for everything else. To predicted rents, vacancy rate, then occupied space, then vacancy, then total stock, new supply, absorption, where is absorption? Okay, so I think everything is there. Finally, we can carry on using this one. So paste special, transpose, yes, and then we can use formulas, right, or values. We hit OK. OK, we go to the solver, we do that again, solve, we hit OK, then we can paste the last values, Control C, Control V, Control C, Control V, Control C, occupied space, cannot see it here, Control V, Control C, oh, Control V, vacancy, then Control C, total stock, prediction stock, then new supply, prediction new supply, then absorption on, Control V absorption. Oh, I hit the one that was not the right one. Control C, and then Control V. Okay, so as you can see, we have these four values. We have calculated these four values. Yes, so I will put the right color for this. I can also know that these values are okay because if you check the first equation, I can calculate the prediction of rent, yes, manually just by using the formula, yes. So I have here the actual coefficients for this net absorption, yes. So I just copy and paste these coefficients here just to double check whether everything is fine. Yes, so for instance, if I do equal intercept, yes, plus this coefficient times what is lack rent, yes, so I need to find lack rent, I think I used lack rent before, I think it's this one, lack rent, yes, plus what else do we need? Vacancy rate times vacancy rate. Is vacancy rate lack, or yes, lack vacancy rate, so this one, plus the ratio of absorption. I think that one is not going to be here. No, it's not here. So times absorption and lack occupancy, okay, I have them here actually, times ratio lack absorption, which is this one, yes, divided by the lack occupied space, which is this one, yes. So as you can see, I am able to say that the solution was actually alright as well, because my prediction rates are actually the same when I use the regression. I cannot use mathematically, calculate mathematically these equations, yes. If possible, that will be a difficult complication because I have three equations and several restrictions, yes. I do remember that it's also possible to find the value for the prediction net absorption. So if I am correct, I use one of these formulas in order to calculate this. The net absorption. Well, the occupied space is equal to the prediction, the occupied space minus the lack occupied space. We already know that. but that is not the one that I would like to calculate. I cannot find it at the moment. Oh yes, so we have as well that from the regression results, yes, we have that net absorption, yes, net absorption, let's put it in here, net absorption equals lack occupied space, we do have the lack occupied space, yes, lack occupied space, where is it? And I think I will have to occupy the space lack is here, plus employment times lack rent. So we have employment, which is a constant for us, times lack rent. What is lack rent? Is in here. Okay, plus office employment. Yes, I do need to set the coefficients, yes, for this equation, and the coefficients are in here. So the coefficients are the following. So let's put the first one for occupied space. So net absorption, and I set this one to this, lack occupied space times C2 plus the next one is the interaction, which is this one, B29 times B2, yes, and then J2 times this one, yes, and finally I just add the intercept at the end, B17, so I have B18, 19, 20, and 17. I hit enter, and as you can see, this result is actually equal to this, right? So I will be able to calculate all this column if I want, just by using the appropriate lags, yes. However, I will not be able to calculate the other results because, as you can see, the prediction occupied space depend of these two, yes, and this one depends on other values, and a total stock as well depend on other values. So that is why I had to use the system of equations to calculate the results. Yes, so after this point, what you need to do is to try to calculate the lags, yes, by using the numbers that we have on this table, yes. So in this case, or the next case for 2017, you will have to record here as a occupied space lag, yes, the prediction that you have in here, this one, yes, that is going to be, oh, no, that is not going to be the lag. For 2017, is going to be this one, yes, 2015 quarter one, because we have a lag of 1 year, right? And the lag for 1 year then is going to be this one. So occupied space, I will just use equal, yes, equal to this, equal to this one. The lag for this one is going to be this one, prediction rent. The lag for this one, absorption lag, is this one. Vacancy rate, this one. Total stock equals total stock equals this one. Let me check if all are in the right row. 19, yes. So I know that the next row is the row 20. So I can actually carry on and inserting here some columns in order to pull some more results, yes, underneath. Yes, oh no, yes, it's the row 24, yes. And well, I just need to carry on copying these values here, right, in order to transpose these values here. Paste special values, transpose, and OK, yes. And then I will go here, data, solver, and then solve. Oh, it could not find a solution. So it looks like I had a problem here in this cell. So I think I copied a wrong value and I already fixed it. So the correct value was in here. I think I copied in the percentage error here in one of these columns, so the solver was not working appropriately. So I Control C and then paste the values of this cell. Hit OK, yes, and then I am able to run the next solver. It found a solution, so I think it looks fine, yes. Okay, so the solution is in here. So I Control C. I can delete first these values, and I think from this point I think you just can copy and paste these values and carry on running the model. I just copy the values in here and like drag these results here, so you will be able at least to carry on calculating up until 2017, 18, 19, 20, 21, 22. Oh, sorry, quarters, 17, 17, 17, 17, up until quarter 2 2018 with these numbers that I have in here. If you insert more rows and you drag back more results, you will be able just to copy and paste the results in here, and then that will bring you the rest of the results. With this I finish my video, guys. I hope you have enjoyed this, and I look forward to see you very soon. Have a nice day. Bye bye.